I think no matter how you slice it, cutting up that much steel is not a whole lot of fun. But I've got it to the point where you can kind of see what this will look like. These Rhodes Shapers had a pretty interesting and unique vise that came with them originally. Chirpy from the channel Chirpy's Tinkering sent me plans that are based on the original vise. There are some changes on this, but it gives me a good starting point. And I've also scoured the internet, found a bunch of pictures of the vise. One of these things that's unique about this vise is it basically just mounts into the table with one bolt down through the center hole in the table. You can see the witness mark on the front of the table here where the base registers. I think I'll start with that piece. With these things being made for more than 50 years, there's some variations in it as it goes along, and the plans are a little bit different from any of them that I've seen, so it gives me a little bit of creative freedom to kind of do what makes sense as I go. From some of the pictures, it looks like that was 2 pieces. I think I'm just going to do it as one. Pour this out to clean it up, turn a piece, and shrink fit it in. I don't know if you can feel that on your screen, but that's really hot. With this thing cooled off, I don't think that's ever going to come apart. My thinking on this setup, the most important thing here is that these 2 faces are parallel and that they're perpendicular with where it registers into the table. So I wanted to do all of that in one setup. Turns out kind of a pain, so now I'm going to flip it around to finish it. I decided to cut this thread as a 9/16 12 instead of a 1/2 inch 13 like it calls for in the print. I couldn't find my thread pitch gauges, so I checked it with the calipers, which turned out to be a mistake. For this thread pitch I needed a 48 tooth change gear, but what I grabbed was actually the 46 because I have 2 of these and the number is not very clear on them. I was watching the thread dial and gauging the half nut on numbers, but it wasn't working out quite right. Won't make that mistake again. But because I did an oversized thread, I think I can turn it down and salvage it. Mistakes happen. Fix it, learn from it, move on. Got some glue on the table to check how this fits. I've been doing some scraping on it. And show you on the surface plate the other side as well. So the top side started out with just contact around the outside. I've got it reasonably good now. It still needs a little bit more work. Bottom side it was all on the inside, and I'm slowly working it out. So what that means is the lathe was cutting kind of this way on both pieces, not totally straight. But this is also going to get bolted onto the base, so it'll probably get pulled up a little in the middle. Do a little bit more here, and then move on, come back to it once it's all together. So in order to do the degree marks on this, I'm going to put the spindexer on the shape. While I'm doing this, I'm going to square up the side so I can hold it in a vise too. I had to set this thing up this way because this would actually hit the table, and I want the marks to go all the way to the bottom here and terminate at various points up here, so it made more sense to do it this way. This is actually a brazed carbide threading tool, but I'm hand feeding this and only going a few thousandths deep, so I don't think it's going to be a problem running it on the shaper. Every 10 degrees gets a big mark. 5-degree marks get a little bit shorter stroke. We'll shorten it up again for the individual mark. I did swap over to using the motor on the shaper, which doesn't make it any faster, but it makes it easier. If you're thinking this seems like it would be tedious, that's because it is. Last one. So instead of doing this bolt pattern like this, I'm going to turn this 45 degrees, put a parallel across between 0 and 90, and then these holes are just going to be on the X and Y. I've got a good bit of material to remove from some of these. I started on the mill a little bit. I'd like to do this on the shaper, but that means I need to take the vise off the mill and put it on here. I think that'll work, and it also demonstrates why this thing needs its own vise. Even though this way will take a lot longer, it'll be really good practice using the shaper. I'm pretty much maxing out both the stroke and vertical clearance on this piece, but it's getting it done. For finishing this off, I've got the head kicked over to 45 degrees. I'm going to hand feed down until I get to depth. This is slow and tedious and quite enjoyable. We're getting to know each other. There's a level of feedback you get doing this that you don't get on a lathe or a milling machine. With your hand on the ram like this, you actually get to feel how it's cutting. And I find myself kind of swaying with it a little bit here. Now that it's to depth, I can engage the auto feed. And we'll let that finish up. For the fixed jaw, I want to do an integrated key in it, like you see here on this one. Keep it square to the vise. This presents an interesting problem on the shaper because these two surfaces need to be coplanar. So I could take a tool that I can cut from either side, walk it in from this side, pull it up, and then walk it in from this side. But the problem then is you end up with a radius in that corner. This is probably exaggerated from what it would need to be, but exaggeration to give you the idea. Could come in with something like this and knock that corner out. Either come in afterwards and try to just knock that corner out and get it coplanar. Do the same thing on this side. Either way, there's a lot of room for error doing that. So what I think I'm going to do here is this is just one of the operations that makes more sense to do on the mill. $14 thousandths to go there. You gotta ask yourself, do you feel lucky? No, I don't. These holes are getting drilled and tapped 7/16. I've set them up so that they match the ones on the mill vise, so I can swap jaws back and forth if I ever need to. The moving jaw gets basically the same treatment, but it also needs a hole through it here with a counter bore, so I popped a center hole in there. If I come at this thing with a drill bit, it's going to hit here and deflect before it gets into that hole. One of the other unique things about this vise is it has these features on the back of the movable jaw, so you can swivel it around and hold round stock in it. The drawings I have are based off of 55 and 35 degree angles, but since all I have is a 30-60 angle block, I'm going to do that. If I touch off on the top corner, I know how far down I need to go for the other features. The other side gets the same treatment, just angled the other way. So, interesting thing, these plans don't actually show where this gets mounted. I think the best thing I can go off is this picture and just make it up. I feel like these sequences where I do one step on each hole work really well for moving the story along, until I forget to video the last step. You've seen me tap enough holes. I've been doing some more of my usual chicken scratch amateur scraping on these two pieces, and I think I've got them to the point where there's a pretty decent amount of contact between them to spread out pretty well. And I think my energy is better spent now focusing on getting this piece to sit on the table well. So why go through the trouble and tedium of scraping this? Well, the more contact area there is, the less likely this is to rock one way or another. It's just going to make it a lot more rigid if I can get good contact the whole way around. It's getting there. I think I've hit the point of diminishing returns on this. I don't think it's going to get much better. This piece has ended up in the scrap bin twice already. Let's see if we can make something useful out of it this time. I waited to take this down to size so that the top is as close to parallel to the table as possible. Everyone says that shapers are slow, but what they leave out is that it's perfectly happy to work away while I do something else. Now to cut the groove for the fixed jaw. Well, that was working well until it wasn't. Let's try a little bit bigger tool. Well, I got this down to depth and then some. Call it clearance. There's a very fine line between enough tool pressure to keep it from chattering, and because I'm out on part of the vise where it's not designed to actually be cutting, too much and it twists. Now I'm just going to walk the tool out either side to width. It's like about another 12 to go. I'm going to sneak up on that. Even with a very sharp end mill, these inside corners are never going to be perfectly square, so I just want to break these corners a little bit. So I need to figure out where I can actually fit these bolts in here. That gives me the spacing for where the screw is going to go. That's the line for the counter bore on the head. Want to avoid these holes. Yeah, probably right there. Maybe right there. Of course, I forgot about these holes on the bottom. But it looks like it'll be close, but it shouldn't interfere. I figured I would try to do this all in one setup and save having to locate features twice. This is the tap drill for a 1/2 inch. The jaw did try to move down a little bit when I was drilling it, so I did put a machinist jack under there to hold it in place. And next the clearance drill down through the bottom part. I might need one more thread in there. I'll run a bottoming tap in it once I have this apart. So I need to put a 7/8 hole down through this thing, which obviously I can't do in one shot. So I've got it indicated in off this side, make sure that it's perfectly vertical. I need to ream this hole for this bushing, made it off camera. Two problems. One, that's going to break through into the keyway. So I put the fixed jaw on there, We'll just cut the clearance I need as we do it. The other problem is I don't have the vertical height to get the reamer in here. If the collet chuck wasn't still stuck, I'd be able to do it. Some of you have given me some really good suggestions on how to get this thing out, and so far none of them have worked. I've got some other ideas on how to do it, but for right now I'm holding off because I'm worried that once I get it out, the spindle taper is going to be all chewed up. So for right now, it works, and I just work around it. It's a little bit looser fit than I was going for. I need this to be stuck in there pretty well because I need to ream this to final size. We'll see if the Loctite can save us. Despite what that had working against it, that worked pretty well. So, let's go double or nothing. I need to put a counter bore on the other end of this. I need to do 1 1/8" counter bore, 1/8 of an inch deep, and luckily I can actually get my boring head in here. I don't have a T-slot cutter the right size, but I do have a Woodruff key seat cutter. Let's see if I can get away with that. Woodruff key seat cutters are not side cutting, whereas T-slot cutters are, so it'd probably be less screechy to use a T-slot cutter. But this got the job done. And the last thing this thing needs is a little radius on here, so that and this is one of those ones that takes much longer to set up than it does to actually machine. I've got a piece of aluminum on here. I've got a cutter in here. I'm going to touch off on this parallel and then machine a fence out of this aluminum. That way it will be the same height as the parallel. That will be good enough for something that's for clearance and aesthetics. And as I tend to do, I've run out of X travel, so I'll just spin this around. That should give me a fence that puts the center of the part right over the center of the rotary table. A bit limited in my clamping options here, but I think this will work. I feel like that was a lot for one video, so I'm going to leave it off there. I'm really happy with how this is coming out so far, and I appreciate you watching. If you want to see me finish it up, stick around.